Solving a right triangle just means find all of the sides and angles that are missing. And you can use anything you want to do that, except for a protractor. Okay, so we look at number 4. The easiest way for us to find P is to subtract 37 from 90. So 90, I'm just going to, if I don't need to show you how to key something in, I'm just going to tell you what I'm doing. 90 minus 37 equals, and you have to do all of them even if it's not requiring that you use incredible trig, and you can use trig if you want. Okay, now we're going to find a side. Okay, using, let's try to do one, since this is the hypotenuse, we can use in SOHCAHTOA, we can use either sine or cosine, depending on which one we want to find. So it really doesn't matter here. Our hypotenuse is going to be on the bottom, which puts our variable on the top, which is nice. Okay, sine 37 equals the opposite side, which is PQ, over the hypotenuse, which is 22. This is the equation I need to see. You can work it out algebraically or you can have memorized it. It doesn't matter. I don't need to see this part. Okay, keying it into the calculator, we say 22 times sine 37. So 22 times sine 37 equals 13.2. Okay, there are two ways we can do this. Probably the easiest way is to use the Pythagorean theorem. I'm going to show you how to do it all on your calculator. So we'll start with that this is 22 and this is 13.2. This is the hypotenuse. So we're going to square the hypotenuse and subtract the side, and that will give us the square of the other side. Subtract the square of the side. So we're going to say 22 squared minus 13.2 squared equals 309.76, and then we're going to do the second function to take the square root of that answer. We press equals and we get 17.6. Okay, let me tell you why I did it that way. The legs squared, 17.6, or in this case we didn't know it, a squared plus 13.2 squared equals 22 squared. To find a squared, we needed to subtract 13.2 squared from each side. And rather than write all that out, I just did it all in the calculator. And we have solved that triangle because we know every side and every angle. Let's do another one. Okay, we need to find the hypotenuse here, and that's c squared. Okay, I'm going to use Casio for a little while. And this is 11 and 18, so this would tell us that a squared plus b squared, that's 11 squared plus 18 squared, will equal this side squared. So, on my calculator, I'm not going to make you write these things down all the time if you don't want to. 11 squared plus, I forgot what it was now, 18 squared equals, now I'm going to take the square root of that, and that gives me c squared. It's 21.09, which rounds to 21.1. 21.1. Okay, now this is where using the original, oh, I said 21.1, I wrote 21.2. See ya. This is where using the original numbers comes in, because 21.1 is a decimal approximation. We have to round. Sabaka, hush. We had to round to get it. So we are going to find P, but we're not going to use this side. It's not going to throw us off a lot, but we're not going to use that side. We're going to say 18 is the opposite side, and 11 is the adjacent side. That's opposite and adjacent, which goes with tangent. So we're going to say the tangent of P is equal to the opposite side, which is 18, over the adjacent side, which is 11. With the Casio, that looks like this. 18 divided by 11 equals, and then do the inverse tangent. And that's 58.57, which rounds to 58.6. So P is 58.6. To find N, we can do 90 minus 58.6, and we get 31.4. Now if you want to double check that and make sure that it's correct, what you would write is tangent N equals 11 over 18, because that's the opposite side over the adjacent side. And you would do this. 11 divided by 18 equals, and then you do inverse tangent, and you get 31.4, which is what we have there. One more time. Okay, this is the hypotenuse, and so that's our C side. So if A squared plus B squared equals C squared, then C squared minus B squared should equal A squared. Okay, so we're going to do the hypotenuse squared minus the leg squared should equal UT squared. 23 squared minus 7 squared, 23 squared minus 7 squared equals, and then we should be able to do the square root, and we get 21.90, which rounds to 21.9. 21.9. Do a reality check. Does that sound about right? It's shorter than the hypotenuse, but a lot longer than that short side there. That makes sense. Okay, using our original numbers, which are 23 and 7, let's find the measure of U. Okay, 7 is the side opposite of U, and 23 is the hypotenuse. So we have the opposite in the hypotenuse, which is sine. So we say sine of U equals 7 over 23. Using the Casio. 7 divided by 23 equals, and this is inverse sine, 17.7. And we look at this triangle and we say 17.7 sounds about right. To find S, we're going to subtract that from 90. 90 minus 17.7 equals 72.3. It's always nice to be able to check your work, so let's try doing this with a function of a trig function. S, 7 is the adjacent side and the 23 is the hypotenuse, so we're going to be using adjacent and hypotenuse, which is cosine. Cosine S equals the adjacent side, which is 7 over 23. And this time we'll use Texas Instruments, and we're going to say cosine, inverse cosine, and we're going to put in 7 divided by 23. 7 divided by 23, and we get 72.28, which is 72.3, which is what we got. Thanks for watching.